Okay, so this one is trig number 5, all right? And just to go back through the whole thing, which by now you're probably getting pretty good at, what's trig stand for?
Trigonometry.
Okay. Trigonometry is basically the study of angles, but for this first 6 lessons, what shape are we dealing with exclusively? Good, triangles. More specifically? Yes, right triangle. Okay, so let's draw it the way it's oriented in the notes. Here's our right triangle. And tell me the names of the sides. What's the name of this side here?
Leg.
Leg, good. What's the name of this side here?
Leg.
Good, thank you. And the name of this side?
Hypotenuse.
Okay, and I'm going to abbreviate it hype, but otherwise known as the hypotenuse. All right? If the reference angle is put here, so let's say the reference, there's only 2 places. We know but that's 90, so we're kind of ignoring it for now. We don't care about it at this point. There's only 2 angles we're interested in, either this one or this one. Let's say we put the alpha here, so this becomes the reference angle. What does this leg's name become?
Adjacent leg.
Adj leg, right? Adjacent because it's next to that reference angle. And therefore this one is across from this reference angle, so becomes the
Opposite leg.
op leg. Op or opposite leg. So, and what I hope you know by now is that if we moved this reference angle to here, now this would be the adj leg, and this would be the op leg. Fair enough? Okay, are you okay with that? So, what is the secret code for remembering the 3 trig functions at this point?
SOHCAHTOA.
Everybody say SOHCAHTOA? All right, thank you, thank you. So here's so, and it's ka, and toa, and the spelling does matter. One time I misspelled it when I was a student, and then you get the trig functions. Doesn't come out right. All right? Tell me what so stands for.
Sine.
Good, keep going. Good. So here's, remember sine and the alpha, sine and its angle, these things flow together as a unit. All right, we do separate them with one of the problems, we pull them apart, but in general, you're going to say sine alpha equals, then what's on top of the fraction?
Op leg.
Op leg, very good. And what's on the bottom of the fraction?
Hypotenuse.
And of course that lines up with sine of alpha equals the op leg over the height. All right, thank you, very good. Let's do cosine quickly. What do I write? Cosine alpha, perfect, equals, now what? What's on top of the fraction?
Adjacent leg.
Adj leg over
Hypotenuse.
height. Very good. Okay, and today's, the TOA. What does T stand for?
Tangent.
Tangent, good. Okay, everybody say tangent.
Tangent.
Right, and your calculator's going to abbreviate it. Tan alpha, what's the O stand for?
Op leg.
Yep, trust yourself. It's op leg over what's the A stand for?
Adj leg.
Adj leg. So now we have these 3 functions. This is the one we'll practice a little bit today and this week, and then we'll try to combine them all and do some other things with it a little bit later. Let's take our first example. All right, given alpha, here's our reference angle, and this triangle, a right triangle. Notice that the 2 legs are being labeled with lengths. There's a length of 10 on this side and a length of 7 on this. Because we're practicing the tangent function in this lesson, we'll go ahead and write tan alpha equals the op leg over the adj leg. All right, let's fill it in. Tan alpha remains this way because we don't know what the alpha is. So this is our unknown. This is the variable right now. According to the alpha being here, what's the op leg in this case?
7.
7. Everybody see how that's the one across? So it equals 7 on top of the fraction, and therefore this one's the adj leg. Both are touching the 90, so they're both legs. So 7 over 10. Now we're going to do this reverse thing where we move the tangent over and it becomes a tangent to the -1. This is like a reverse tangent. So if we're going forward with tangent, it would stay this way. Since we're going to reverse it and go backwards, we do a tan to the -1 over on this side of the equation. Drop in the 7/10. Do you have your calculators ready? Are you practicing? Try to practice these on your calculator. See if you can do it quickly. And see if you can do this one without me. And then we'll fill it in. If you don't get it, we'll help you get it. Are you getting a 34.99 degrees? Who else got it? Natalie, you got it? No? You do have to press equal at the very end. Yeah, because you know what's happening. I don't know if you have to press equal at the very end.
Is it?
I kind of stand corrected on that. No, you don't. I take that back. You do not have to press equal at the end.
I got 3.499.
I think it should be around 34 degrees, so I think this is right. Everybody with an iPhone, ready? 7 divided by 10 equals. That's where the equals is. Second key, so the tan turns into -1 tan, a reverse tan, an A arc tangent, and then tangent to the -1. Do you get 34.99? Yep, I got more over there. Yep, okay, I got some head shaking. Natalie, how you doing? No, not yet. You're on like a Android device, right? So for yours, clear. Make sure you're in degree mode. Oh, okay, good. Now do it directly. Say inverse, tan to the -1, and it gives you parentheses, perfect, and drop this in the parentheses, 7 divided by 10. And say equals. There you go. Yep, we got it. You got it, you got it? Natalie, you got it? Nice. Okay, let's do one more. Let's change the orientation of the right triangle and go like this. $34 degrees. Let's see what we got. Question mark, and this is 15. So just some thoughts on, right now all of our problems are tangent, but at some point you're going to have to choose. Do I choose sine, cosine, or tangent? Why are we choosing tangent in this case? Because the two given sides are both legs, adjacent according to this one and op here. So that makes this a tangent function. If we were given different measurements of the different sides, like for example, say they gave us the hypotenuse length, now we would be considering using sine or cosine. So right now it's a little bit easier because we're rolling through sort of deliberately. So this one's going to be tangent alpha equals op leg over adj leg. Tan, in this case we have the measurement of the reference angle, 34 degrees, so that goes in. The op leg in this case is an x, it's across the ways, and the 15 adj is here. We're going to do a little bit of algebra, multiply both sides by 15. 15 over 15 is 1. The x comes over here and is approximately equal to, let's rewrite this, 15 times tangent of 34 degrees. Okay, see if you can type that in your calculator quickly. And the Android process or computer process, what you're doing is just straightforward. You go from left to right when you type it in. The iPhone is strange. You go sort of backwards. You go from right to left. You type in 34 tan times 15 and go the other way. I think that's it, 10.12. And it comes out 1-1. And do you see that I'm rounding that one digit to a 2 because there's a 7 next to it? 5 or higher next to it makes it round up. Okay, how you guys doing? Did you guys get the other one, by the way? Good. So you're dealing with iPhone, so you're going backwards. You're going 34 tan times 15.
Oh,
You're going forward. You're going 15 times 34. Nice. Good job, you guys. Okay. Okay, did you get it? Did you get it? Did you get it? Did you get it, Sheldon?
Yeah.
You sure? Tell me now. Got it? Okay. Did you get it? Got it. You got it. Okay. So, let me check vocab. So maybe at this point, you're starting to think about the algebra more. You're starting to think about how did we get so we're filling out a formula here, right? We're filling in the op leg, the 7 and the 10. Now we've got to get to something through algebra that shows us the angle equals and something to put into our calculator, right? This process by moving, when we need to solve for an angle, the tangent comes over to the other side and becomes this inverse tangent or arctangent. Think of it as the reverse of tangent, right? What's the opposite of multiplication? Division. What's the opposite of a tangent going forward? A tangent going backwards. Does that make sense? It's like the forward and reverse of math, like addition. The opposite of addition is, right? So this is yet another forward and reverse. Now in this case, we had the angle, so we didn't need to use the reverse. We used the forward, and we did the algebra here to solve for the x. And this is where it becomes a little bit complicated, especially since we teach algebra after geometry. So it's a little bit, you have less equation solving practice. All right? Okay, let's stop it there.